Hello, Algebra 2 students. This is Mr. Sands here. We're starting section 2 of chapter 7, day 2. So this is not the first lesson, this is the second lesson that follows up the first one. So we're going to start with a little bit of review of what we did in the first section. We're going to do 17 times 5, which would be 85. Now the fourth roots are both the same root, so we can do 2 times 64 here. Okay? So I got 64 times 2, which is 128. I don't know why I wrote it again. Probably because I was thinking like cube roots here. That would be 128. Now we're going to try to find numbers that go into 128 from our fourth root list. And it looks like it's going to be 16. Okay, so I'm going to go 85, fourth root, 16 times, I don't know, what we got here? Yep, 48, 80, yep. So 16 times 8 is 128. Let's do the 16th root of that. So that would be 85 times 2 times the fourth root of 8. And this would be, excuse me, 170 times the fourth root of 8. And that will be it for number 1. Number 2, we have 9 times 1, which is 9. And then we have 4 times 28, which would be 512. Now, as far as 512 goes, 512 divided by 2 will give us the perfect number to the fourth power of 256, which is times 2. So this is 9 times, well, the fourth root of 256 is 4 times the fourth root of 2. So we're looking at 36 times the fourth root of 2. All right, so that's what we did in 7.2 part A, or day 1 notes. Now in day 2 here, we're going to start looking at adding and subtraction of radicals. Now to add and subtract radicals, they have to also have the same root, but also the same base underneath the root. So what they did from here to here is they found factors of 176, one of which we can take the fourth root of. There you go, fourth root of. Now, from here to here, all right, take the fourth root. The fourth root of 16, which is 2. From here to here, they did 2 times 4 to get 8, so they multiplied. And then from here to here, see all these fourth root of 11? Fourth root of 11, they match up. So we do 8 plus 9. So we add 8 plus 9, then rewrite our fourth root of 11. All right, so there is basically the steps that we're going to explain. Now let's actually go ahead and do a couple of these. So the directions are asking us basically to simplify or perform the indicated operation. We cannot combine these right now, so we got to try to break them down and see if they have the same base underneath the radical, and then we can add or subtract them. Right now we can't. They have the same radical, so that's good, but the 3075 is not the same as 81. So we're going to make this 125 times 3. We're going to make this 27 times 3. Now the cube root of this is 5. The 3 we can't do anything with. The cube root of 27 is 3. And then we're going to do 5 minus 3, which is 2 cube root of 3. Alright, going to 2. Alright, we're doing cube roots again. So I know 27 is a cube root. So this is 27 times 2. You take the cube root of 64. So this is 64 times 2. So this will be 5 times 3 times the cube root of 2. This will be 7 times 4 times the cube root of 2. So this is 15 cube root of 2 minus 28 cube root of 2. So 15 minus 28 is 13, and it's negative cube roots of 2. And 3, okay, we're going to have to break this down. 16 is not a perfect cube, but 8 is, so we'll make that 8 times 2. And 81 is not, but 27 times 3 is 81, and 27 is a cube root. So I'm going to pull the 8 out, but that will be 2 times 10. So I got 10 times 2 times the cube root of 2. This will be 3 cube root of 3. This is 20 cube roots of 2 plus 3 cube roots of 3. And then I add this. Oh, wait, but you can't add them. Even though they're under the cube root, the base 2 is different than the base 3. So therefore, you are not allowed to add those together. So you would be finished at that point. Okay? And then a 4 here. Fourth roots. We can do the fourth root of 16. So 16 times 2. And over here I can do the fourth root of 81. So this is 6 times 2 times the fourth root of 2 minus 11 times 3 times the fourth root of 2. The fourth root of 81 is 3. So this is basically 12 times the fourth root of 2 minus 33 times the fourth root of 2. 12 minus 33 will give us negative 21, 4 roots of 2. Okay, so that's that. Going to 5. And in the fourth root column, we have 256 times 2. Give us that 512. And again, we can do the fourth root of 16. So this is 2 times 4, because the fourth root of 256 is 4. Cannot do the fourth root of 2. This is 15 times 2 times the fourth root of 2. So this is 8 fourth root of 2 plus 30 fourth roots of 2. So that's a grand total of 38 fourth roots of 2. All right. And last but not least, square roots. Oh, finally, something that is a little different. 16 times 3. We'll make this 100 times 3. So this is 12 times 4 times the square root of 3. This is 15 times 10 times the square root of 3. So we have 48 square roots of 3 minus 150 square roots of 3 to leave us with negative 102 square roots of 3. So there's your front of your notes in 7 minutes. We'll see you on the back page here in a second. All right, we're on the back now. Let's go ahead and take a look at 7, 8, and 9. Best way to probably approach these is to break them into separate radicals. So I have the fifth root of y to the fifth on top, and I have the fifth root of x to the fourth on bottom. This will be y to the 5/5 times x to the negative 4/5. Now remember, it gets the negative because I was in the denominator with that x. So when I move it to the top, it gets the negative exponent. And then the last step here, once we go to exponential notation, I'm just going to reduce 5 over 5 to get 1. Negative 4/5 is in lowest terms. I'm going to leave it as such. Okay, with number 8, we're going to go through the same process here. We go, okay, this is y to the 6th under the 8th root over x to the 13th under the 8th root again. We're now going to write this in exponential notation. So this is 6/8. And this is x to the negative 13/8. Let's go ahead and reduce our 6/8 to be 3/4. And the x, well, that exponent cannot be reduced. Okay, y to the 3/4 times x to the negative 13/8. And 9. Again, rinse and repeat. It's kind of like conditioner. You know, keep going until you get the desired product. Sorry, that's not, let's try this again. Z to the 30th and 14th root of that. So again, this is y to the 20 over 14. And this would be z to the negative 30 over 14. Let's go ahead and reduce these. So that's 10/7 because I divided both by 2. This would be negative 15/7 because I divided those both by 2. And there's 9. I'm going to go ahead and do 10 through 13 while I'm here. All right? So x is clearly larger on top, so x stays on top. 4 minus 1 is 3. With the y's, y is larger on bottom. 7 minus 1 is 6. So x to the third over y to the 6th. With 11, okay, I'm going to have x on top because 4/3 is larger than 1. So I'm going to do 4/3 minus 3/3. As far as the y's go, again, the y up top's larger because positive 1's more than negative 6/7. So this would be 1, which is 7 over 7, minus a negative 6/7. So when I do this math, and if you want to put it over 1, you can, but nothing's left on bottom. So this will be x to the 1/3 times y to the 13/7. Now remember, 2 negatives make a plus. This turns into a plus. 7 plus 6 is 13. That's how I arrived at that final answer. Again, if you want to put it over 1, you can do that. Now you can notice 12, excuse me, is the same thing as 11. The only difference here is we have the z on here, which doesn't change the x's. The x is still larger on top. I'm going to do 4/3 minus 1, which we know is 1/3. Okay, so that's 1/3. Y is still larger on top because this is 1 and this is -6/7. Positive 1 is bigger than -6/7. So y is going to stay on top, and I'm going to do 1 minus -6/7, which is this again. So this is still 13/7. And this z to the 4/3 stays right where it is. Okay? And 13x here, okay, we have a 1 being compared to a -3. Positive 1's larger, so x stays down here. And then I'm going to do 1 minus -3. So 1 plus 3 is 4. Y 9 is bigger than y to the 1st. Y again is on bottom. 9 minus 1 is 8. Now, nothing's on top, so we put a 1 in there so we can have our fraction fit. Okay? So there's that set. We have one set left to go, which is the asterisk problems. So, we're going to break all these cube roots down. So this is going to be the cube root of 27 times 2. This is going to be the cube root of 64 times 2. And then this is 8 times cube root of 216 is 6. All right? So there is no cube root left in this one. But over here, this will be 5 times 3, cube root of 2, minus 7 times 4, cube root of 2, plus 48. 5 times 3 is 15. 7 times 4 is 28. This is just like the one problem on the front. It's just this time you have this plus 48 on the end. The back here. 15 minus 28 is -13. Cube roots of 2 plus 48. Okay, that one's finished. Let's go to 15. Now the first thing we want to do in 15 is we're going to reduce these y's. At least I'm going to. So this will be the 8th root of y to the 4th on top. Y to the 18th is gone on bottom. So I got the 8th root, y to the 4th, over 8th root of w times x to the 10th. Let's go ahead and put this in exponential notation of 4 over 8, w to the -1/8, and x to the -10/8. And now I'm going to reduce these down. So my final will be y1/2, w to the -1/8, and x to the -5/4. Okay? And last but not least, number 16.
Are you just teaching yourself?
Right. So I have 2 x's on the bottom. Okay? So we have the x's on bottom. I'm going to put these together. So I have x to the -5 over 22, y to the 1st, z to the -6/7 over. Now I'm going to add exponents. So that's 1 plus 4/3, better known as 3/3 plus 4/3, because this is 1. So I have x to the 7/3. I have y to the -6/7, and we still have this z to the 1. So x is larger on bottom. So I'm going to have 7/3 minus -5 over 22. I was lucky enough to do this earlier. So there's 7/3 minus a -5 over 22. You get that 169 over 66. Now, for the y's, we already did this, okay? So we have y to the 1st is larger on top, and this would be 1 minus -6/7, so that becomes plus. So this is 13 over 7. Z is larger on bottom. It's the same thing, 1 minus -6/7, which is still this. So this is 13/7 again. And that would be it for this section. That was not the easiest thing in the world, but remember you guys do have calculators in the test. Questions, you know where to find me. Have a great day, guys.